thank you everybody for joining. We're looking forward to hearing from David, who volunteered to share with us some of his open source software development and his experience in the process. Thank you very much. Thanks all for joining. Thanks. So the floor is all yours, David. Thank you very much.
Thank you, Tobias. And it's fine. Even in my own family, they cannot agree how to pronounce this. So David. Well, thank you for giving me a platform to present. I'm super thrilled to be here to present a new piece of software that I have created. And well, I have published several desktop and mobile applications, and I'd say that developing something is, of course, the easy part, right? You can always come up with something, but developing something that is actually useful for someone, that is kind of the harder part. So I think with the NeuriGUI, we bring something really valuable to the table. So the NeuriGUI is free and open source software in the spirit of the LIBREhub, right? And it is developed in the bring your own device fashion, BYOD, and I will explain towards the middle what I mean by that. First, let me actually also ask, the important part is that you see my face, not because my face is important, but because later then I will show some stuff. So I hope my camera is still visible. So first,
yeah, that works perfectly.
Nice. So first, a little bit about myself. So I'm a doctor in neurophysiology. In 2019, I moved to Chile, where I started a postdoc on brain-computer interfaces. 2 years later, I've co-founded a neurotech company that is called Helmand. And this year, eventually, since this year, I'm a research engineer at InteraXon, which you might know because they are the creators of Muse. And yeah, I said I have developed several apps. So I'm a hobby program developer under the name of Soft Coding for You. Well, the name and the logo are what they are, right? I'm not a designer, so feel free to mock me for that. That's fine. But this is essentially what brings me here today. Because the NeuriGUI is a graphical user interface that allows you to explore biosignals in real time. So biosignals are data of your body, or signals of your body, physiological signals that are recorded with a biosensor. And of course, biosensors come in all shapes and sizes, right? So on the top, you have an example of what I would call a more or less bulky setup of OpenBCI. And on the lower part, you have a device that is focusing more on ultra portability, comfort, which is the Muse S. And of course, each of these devices come with their own graphical user interfaces, right? You can see that. So they're there so that you can explore and visualize your data in real time so that you know what's going on with the signal. And usually they make available in real time the signals so that you can actually take in real time the signal, process it, and create your own protocol of, for example, neurofeedback. So which is, for example, playing back a sound to the subject, to the person that is being recorded. And usually also they store the data on your hard disk so that you can access this at any time later for offline analysis, right? And in this context, I am offering the NeuriGUI, which is a graphical interface which you can connect a biosensor to, and that allows you to explore in real time your signal, stores the signal on hard disk, and also makes available in real time the data, so forwards the data in real time so that you can plug in any third-party applications for, let's say, neurofeedback. And at this point, you might wonder, why am I mentioning, or why am I bringing to the table yet another software if the output is exactly the same as for the other two GUIs that I just mentioned before? Well, this is because I did not specify what is on the left side of this equation, which is, okay, what biosensors we can actually connect to the NeuriGUI, because the answer here is really any device. You can plug in, as long as from the biosensor you can extract the signal, you can easily plug it into the NeuriGUI. And that means that on the other side of the spectrum, the output is always the same. There's a standard protocol of output. So you always have access to the same visualization tools. The data is always stored in the same fashion on your hard disk, and the data is always forwarded in the same format so that you can, so that you have a standard, you can have a standard set of, a standard way of connecting your third-party applications to it, right? So in the end, the NeuriGUI is really just a common entry point that produces a standard output. In other words, let's take a real world but theoretical example is that you have Alice on the left. She has an OpenBCI biosensor, and Bob on the other side, he has a headband from Muse. So that means that when they plug in their devices to the NeuriGUI, they can work on a common project because the output is exactly the same. So it really enhances collaboration in my opinion, and it is in the BYOD fashion, right? So I mentioned this. It means bring your own device. So you can have your own device, and yet collaborate with other persons that have other devices. So some advantages of the NeuriGUI are there's a parameter window and an arrow window. Personally, I really like the latter because I find it always frustrating when you take a tool from the internet and it's supposed to work, but when it doesn't, you are just left alone because there's no feedback. What has gone wrong, etc. So I was really focusing on that to give like real user feedback. Okay, this is what you have done wrong. This is why it's not working. Signal forwarding is local or over the internet, so you can stream the data over internet even. You get a template for your own device, so that means that with minimal code changes, the template is prepared for you, and with minimal changes, you can adapt the GUI to your own device. You can plug in third-party apps. I will present some essentials and a live demo. And the GUI is compilable into a single executable, right? We are not all programmers, and it might seem a bit intimidating to run something from a command line or even in a developer environment, etc. So you can even compile this in a single executable and just double click. So yeah, I mentioned there's templates for you. So that means to fully integrate your device into the NeuriGUI, you only have to adapt two functions. One which is reading the data from your device, and the other one which is transforming the data that you just got into a predefined NumPy array in that case, so in a standard format, so that the GUI can actually work with the data. And you also set 10 basic parameters. So these parameters are like, okay, does your board need a start code to give it green light to actually start sending you signals? What is the sampling rate of your biosensor, etc., etc., etc. So you see, it's really, I think, straightforward, but especially moreover, super fast. So yeah, third-party apps. I mentioned this now quite a lot, right? So the essential structure of any third-party app that you want to plug in to the NeuriGUI is it just has three parts: connect to a local or internet data stream. If necessary, perform like basic pre-processing, right? So you probably want to, let's say, bandpass filter the biosignal. And then lastly, to trigger an action when you pass, for example, an amplitude threshold. When the signal passes a certain threshold, you want your program to do something. So these are the three only parts that are needed. So with that, let's move to some live demonstrations. So I have talked enough. Everything that I will show is available on GitHub, right? So you have the QR code here. It's also presented on a slide towards the end. But yeah, I'm just gonna show some programs that we have developed with the NeuriGUI. So let's start the GUI. So this is how you start the NeuriGUI. First, you are presented with a parameter window. It's adaptive, so you can resize it, and it's scrollable. You see on the top right, it gives an information about the new version that is available. If you click on this, it takes you right to the download website. You can select the compatible boards. So right now there are 4, but there's actually a 5th one coming. And as I said, any device can be compatible with this, right? So I'm going to use the board. You select the board, you set some basic parameters, and you can choose which channels to plot. So there's also some real-time feedback. So now I deselected all the channels, and the GUI just notifies me that, yeah, you should at least select one channel, right, for the display, for the visualization part. So now the GUI is not happy because I have not selected any. And I can also just rename the output file to anything that I want. And if I really don't care about the visualization part, I can check this box and run the GUI headlessly. So that means there's just a small static window that you get on your screen to notify that that the GUI is actually running in the background, but there's no visualization and whatsoever going on. So if I just say save and start, you see there's an error screen, right? As I said, I find it super frustrating when there's no feedback on what has gone wrong, if things are going wrong. So I focused a lot on this, and this screen gives you a list of errors that the GUI has encountered in when it checked for the parameters that you gave it. So now we only have one error that says no channel selected for display, please select at least one. So we know exactly how to solve this. So if we then close it and start the GUI again, let's select at least one channel. So this is the graphical interface. That's the main window. And you get some basic options for the visualization. So you can set the vertical range, let's say 200 microvolts, anything, and even a custom one, or you can just leave it at auto so that it adapts to the minimum maximum amplitude. So you have a notch filter, and you have several bandpass filters. You can display the envelope of the signal. And let's say if I introduce a bit of noise, you want to take your time to inspect the signal, so you can just click on stop, take your time, have a look at what is going on here, and if you're done, you just resume, right? So, well, the visualization is resumed. The GUI is running in the background continuously. And believe it or not, one of the first features that I have been requested to implement was the dark mode. So I got you covered with that. Here we have a dark mode, right? It's modern times, I get it. Everyone likes the dark mode nowadays. So what is being displayed right now is my cardiac activity. I have under my sweater, I have some electrodes connected to me. So that's why you see in real time now my heart activity, cardiac activity. So let's go ahead and show you some third-party application. As I said, everything is available on GitHub. So this is an application that we created for a workshop, and this was focusing on educating people. So what we did with this year is just writing a small window that is taking the data in real time and doing some pre-processing and allow the user to set a threshold. And every time we cross this threshold, we change the color of the screen, right? So it's like turning on an LED, let's say. So whenever we detect a heartbeat, now the signal is not smooth because I'm talking, I'm moving, etc. But if I just be quiet for a couple of seconds, you see that the screen changes at every heartbeat based on the threshold that you choose. So this was really just for education. And it might seem gimmicky, right? So in the end, all that we do is change the color of the screen. But just as a thought experiment, think of a hospital and beep, 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 beep is an important indicator of a patient's cardiac activity, right? So I don't mean to say that we should apply the NeuriGUI in that area. It's just that you can easily extrapolate something that is that seems like a side project to something that has actually a real world application. So let's show something else. This I shouldn't be showing you because it's the accuracy is not great yet. So if I just plug in the electrodes on next to my eyes, there we go. Oops, come on. Should stick. what you get here is a yellow rectangle that I can actually navigate through to the labyrinth to reach the red spot with nothing but my head movements, right? And I said the accuracy is not great yet, so that's why I'm struggling a bit. But it is kind of fun, right? So it's in the same spirit of like educating maybe people, or even creating like fun projects. You can easily imagine this in a class setting, like a teacher having a class and then just run some fun competitions, right? Whoever reaches the red spot first, and etc., etc. So I think it's really cool. And again, the programs are available on GitHub, and they are crazy small. So with a couple of lines, you really can get started easily. So let me close this and go back to the presentation. So these here are in the end just the same videos. I just had them as a backup in case things are not working great. And to finish, just to give you a small idea how quickly you can actually get started in neuroscience in general, and maybe especially with the NeuriGUI. So on the lower right, you have an example of a BioAmp EXG pill, which is a biosensor developed by Upside Down Labs. This is an Indian company I have been in contact with, and I have adapted the GUI for their boards. And they sell a low-end device for roughly $35, right? With an additional $3, you get some electrodes, which are actually gold cup electrodes on AliExpress, and you are really ready to go. You can do neuroscience at home or in whatever setting. You might want to move a bit up. So the Muse S, for example, is a research-grade device. So you get better signal, of course, and it costs less than a smartphone still. So you can. This is just to give you an idea how quickly you can get started with this. And with that, I'm just going to finish. So on the left, you have the GitHub link that directs you to the NeuriGUI. On the right, you have the links that allow you to contact me or to check out other developments I'm doing. And if you're curious about what I'm doing over at InteraXon, well, check out musehealth.ai and choose muse.com. And with that, I will be happy to answer really any question that you have.
Thank you very much, David. You can hear me? Yes. And in fact, when we earlier discussed about your seminar, you were keen on also sharing with us a little bit your journey into open source and how you think that's a great platform for also career development and opportunities. So would you like to take a couple more minutes to talk about that?
Yeah, sure. So what happened is that I created co-founded the neurotech company, right? So Helmand. And we developed these boards that are called the Neuri board. And for these, actually, we had initially developed the GUI. And we wanted to commercialize everything. And eventually, the company came to a halt. And we just really open sourced everything so that it doesn't disappear just because the company is disappearing. Useful tools should not disappear. So we open sourced everything. And I was then looking essentially for a job, right? And I contacted InteraXon, and we got in touch. And in the end, you are just one more candidate because there are many. And what stuck out actually to them is the fact that I have a track record that I can also show to people. And this is where open source really was important. I could actually show them what I have done. And also it makes sense to open source things when you, for example, the NeuriGUI, I'm one guy. I'm one creator and I'm one maintainer. And in order to get things going, to gain a bit of visibility, what is greater than just open sourcing it so that people can actually use this really for free, study the code, bring in modifications and enhancements, because again, I'm just one single person, right? So working by having 2, 3 or more people working on this, this will be a great quality enhancement. So, but in the end, what leveraged the fact that I wanted to get the, experience maybe outside of academia, because I was always in university, so I wanted to gain some experience outside, is the fact that I could actually show stuff to people.
Yeah, that makes a lot of sense. I think similarly, but many of our open source things, it's a great opportunity for people to showcase their work, but also to be able to continuously own the work they've been working on. So if you do a PhD, I guess, with where you develop a lot of things, sometimes it's not so easy to keep using that or implementing it somewhere else if it's not open source.
Yeah. And also, I mean, we are not also in the scientific field, I would add to this, we are no strangers to the fact that we build everything that we develop, we build on something that is already there, right? Whether it's scientific literature or a programming tool in my case. So why not? Yeah, I have to say, it is a great gratification actually to feel like I'm also giving back.
I'm glad you feel that way. Thanks for sharing. So this, I think you haven't mentioned it. In which language do you develop your software?
That's Python. And whenever you want to develop a graphical user interface, and you mentioned that you want to do it in Python, I promise the first answer is like, maybe don't, because Python is slow, blah, 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 blah. And there is something to it, but Python here, I don't have a programming background. I'm not a professional programmer. And I learned this from scratch just by doing. So Python yet again demonstrates that it's just an excellent language to get started, to build something super quick. And yeah, also I coded this in a way that it is actually also compilable. So this is compilable into machine code. So speed is not an issue anymore, but it's 100% Python.
Yes, so we have a question for David from Germán Fernandez. He was mentioning whether your system is compatible with NWB files. Maybe can you explain what are these files and if they are proprietary or open source also?
I cannot. NWV.
Yeah,
I have to admit, that's the first time I hear
it. Germán, would you like to explain better? 1 second, let me give you.
Hi. This kind of file is a kind of format of file where you can organize and present all your neuroscience data. It's the compression of neuroscience without borders. It's a kind of new, I don't know if new, but it's a kind of standardized way to present the neuroscience data.
I mean, I hope it's new, because otherwise I would have missed out on something that seems super great. A centralized tool, especially in the open source world, right? So I assume this is also an open format.
Yeah, it's
great.
Actually, it's an open source, and you can include time series data, behavioral data, and other kind of data in just one file.
All right. Yeah. I mean, you mean whether the NeuriGUI can be adapted in a way that it writes to this data format for offline storage? Is that what you mean?
Yeah.
For sure.
Right.
For sure. I mean, really. Oh yeah, no, for sure. I mean, it's certainly possible. Yeah, right. Because the limits here are just whatever limits are Python based, right? So once you have the data, you can do whatever you want with this. Right now, I'm storing in text format because it's just the simplest one I could come up with. But yeah, this can certainly be an option. Let's say, for example, in future, to select in the parameter screen what is the format that you want and to adapt it. Yeah, for sure.
With that, I would definitely like to thank you one more time for sharing this with us online and with the YouTube audience. And it's nice to be in touch again. And so I hope we'll hear from each other.
Yeah, glad to see you, especially since I come from the same area, right? So glad to see you again.